All right, so we are still doing algebraic fractions, my plebs. So, what are we doing? Fun stuff. It's all fun stuff. Algebraic fractions, what are we doing? Cool, but what are we doing? You guys are not helping me much here. Come on, what are we doing with this one? We're on to this one. What do we do?
Operational algebraic fractions. Simplifying fractions.
They said 34. How? All right, for a start, we've got a fraction with all this algebra stuff divided by another fraction with all this algebra stuff. Who wants to divide fractions? Then what do you want to do?
Put them together.
Well, how do we do that?
We simplify.
Dividing fractions. Going peeps. How do we divide fractions? You are just making stuff up now. If I have 1 over 2 divided by 1 over 3, I can't do that off the top of my head. What do? No! Change the bottom. You multiply. Thank you. You multiply by the reciprocal, or you invert and multiply. Any of those particular terms that you want to use. Don't forget, this is stuff that we did last year. At the end of the year. Yeah, I know. Well, it's not my fault you were over there being all Chinese and stuff. It's like killing me. Oh, that's... You reckon the Asianness rubbed off on him, and now he's mathematically brilliant. It should have. Oh my God, let's go stereotyping. Let's go stereotyping, thank you. I wish this was actually a video so that everyone could see the look on your face. All right, so, unfortunately, our token white Asian guy, I got a mate, my friend's a Filipino, but Bindi's white, Jerome is Filipino, and his mum Lola is Filipino, and the kids look Filipino and all that, but Bindi is white as and like all that. But Bindi's one of my best friends. Yes, she is. Yeah, Jerome is her husband. Yeah, he's Filipino, and but their son Jamie, who's about Bryn's age, refers to himself as Bayesian. He's not quite white. He's not quite Asian. He's not quite white, so he's Bayesian. Beige. Beige.
Beige. Oh, that's crazy.
So anyway, I'm going to be down at their place on Friday night, so I'll play this recording for Jamie because he loves it. Yeah, he's our little Bayesian. All right, so we've got to invert and multiply with this. So first thing we're going to do is rewrite this, aren't we? Caitlin. I was going to call you Catherine, so be careful. Yeah. First thing we're going to do is rewrite this with the multiplication. Okay, we're going to invert and multiply. So I'm going to write it over here just so I don't take up too much space. 2a squared b over b cubed plus 27 stays the same. We're now multiplying, and we do that, we invert and multiply. Because remember, no, I'm pretty sure I haven't. Yeah, that bit wasn't very important. I better put it up. Okay. I think I probably should. So I wonder if I can edit this enough so that no one knows that you knew something that I didn't. Remember that division, and I was too busy trying to think of this part. Division and multiplication are inverse operations. So hence we are inverting and then changing the operation. So we now have 4b plus 12 over a squared minus 25. All right, so we have inverted and multiplied, or we've inverted, we're about to multiply. Now, what should we do? Should we just go and multiply or what?
No,
No, you have to simplify.
no. Can we do like...
What is it?
What? What you guys are. So, are we going to find the... What's it called?
Don't know. What are we doing?
Excuse me.
Yeah.
Are we going to find the...
3 minutes and 41 seconds. Shit.
Guys, I need you to focus on this because otherwise you're going to be doing a lot of these and you're not going to know how to do them. So what do we do now? Have a look at them. There's a lot of difference in them. What have I told you? The first thing you do when you've got something here. Collect like terms? Not quite. You're on the right track. That's the last thing we do. What's the first thing you do when you're looking at these? Factorise. So finding common factors is a type of factorising, but you are going to factorise. Yeah. Yeah, just the right-hand one, yeah. Invert and multiply. Or multiply by the reciprocal. So what we're going to do is we're going to factorise these. All 4 of these can be factorised. There's 4 lots of terms I'm thinking of. Numerator, denominator on the left, numerator, denominator on the right. I want to factorise all of them. Yeah? So, let's have a look at that first one. 2a squared b plus 10ab. There's only 2 terms, so we're not going to be grouping by pairs. It's not a full quadratic, so we're probably not going to be doing binomial. What do you reckon we're going to do? Go for the simplest one first. And it's the one you said. Yeah, pull out common factor. What are the common factors in that? 2a and b. Yeah? 2 is common to both because 2 goes into 2 and it goes into 10. A goes into a squared, it also goes into a. B goes into b and into b. Okay, so, well, at the moment I'm pulling the 2ab out. So if I do that, what's left on this left-hand side? A. And what's left on the right? That's it. Because 2ab times 5 will give you 10ab. That all right? So the way to double check when you've done that, you've pulled out what you think is the common factor. Have a look at it and go, okay, 2ab times a will give me 2a squared b. Excellent. 2ab times 5 will give me 10ab. Excellent. Cool. Now we're going to do the denominator. Have a look at it. It's a cube and a sum of 2 cubes. You sound like a Dalek. All right. What?
I knew it, but I couldn't get it out.
It is awkward to get those words out. Sum of 2 cubes. They're all single syllables. Difficult. Is cubes a single syllable? Do you reckon? Is it a 2 syllable? Okay. All right. So that's great. All right. So sum of 2 cubes. What do I get? You guys have got the formula. Yes, we do have b, which is cubed, and we have 3, which is cubed. So someone's got to read it out. You've got the formula. I'm not expecting you to memorise this one. It is on your formula sheet. Yeah, 3 cubed is definitely 27, and b cubed. So we've definitely got a sum of 2 cubes. So now from the formula, how do we factorise it? A. Read out the formula. Sum of 2 cubes.
Sum of a cubed plus b.
Yep, that's that side. Now the other side.
A plus b.
Okay, whoa, one of ya. A plus b. So we're going to have b plus 3. Yeah. B squared.
B squared
Minus.
AB.
Okay, so I'm going to do a times b, which will make it 3b, yep. Plus 9. Cool? Because remember, in this case, like a and b is just the first and second term. You've got a cubed plus b cubed, right? It's just first and second term. In our particular one, I could turn these round and have 27 plus b cubed, if that makes it prettier for you. It doesn't matter. That's our a, that's our b. In this case down here, that's our A, that's our B. Okay? Yeah, first one is A, second one is B. It doesn't really matter as long as you've got it, the minus in the right spot. You happy with that? So I've just taken my A and B and put them in there. Okay? Think of A as the first term, B as the second term. Don't think of it as being, oh my God, it's B. B is that one. No. A and B is the first term and the second term. Cool? It could be X and Y. It doesn't matter. Okay, just the first term and the second term. All right, so we've done that one. And now we've got times. And what are we going to do on this other side? 4b plus 12. What are we going to do? Factorise it in what way? Thank you. You guys are taking too long. 4 outside of b plus 3. This should not take very long. You should be able to look at it and go, well, how will I factorise this? This one has a 4b and a 12. There's no common pronumeral. I'm not going to be doing product cubics. I'm not going to be doing anything like that. Find a common thing. Only thing common is the 4. Done. Now I look at the bottom one. It's a squared minus 25. I look at that and go, a squared is a square. 25 is a squared, and it's a minus. So okay, a minus 5, a plus 5. It should be as quick as that. Okay? I am a maths teacher, and yes, it will be quicker for me. Approximately 3 times quicker is what we average. Yeah. Anything that I set for you should take me 3 times less. Or a third of the time is probably a more accurate way of saying it. Yeah. So if I expect you to take 60 minutes, it should take me 20. But it depends what it is. Once you get up to extension maths, it's not going to take me a third of the time. I'm good. I'm not that good.
Anyone other than robot doing this?
No, it means you should be more mathematically capable. So things like this should take less time. No. But when you are. Not yet. It takes time. It's not something that happens. When I started doing this sort of thing, I wasn't as though I was your age and able to do this straight away. Maths isn't, yes, it is a talent, but it's a learned skill as well. It's like kicking a football. Sorry? Did you? Who? Oh, that's all right then. Wasn't one of mine. It's okay. Yeah. Yeah. General does. Okay. We better finish this, guys. We better finish this. Hello. Hello. Got to simplify it. But how can we simplify?
Cross out
When you multiply fractions, you just multiply the numerators, you just multiply the denominators. If I did that, I would have an a plus 5 on top and I'd have an a plus 5 on bottom. They cancel each other out. Does that make sense?
Yeah.
They are common to the numerator and denominator. They can be cancelled out. It's all multiplication. There is no additions in there anymore. You notice that? There's no addition. If there was additions or subtractions, I wouldn't be able to just do that. Okay? But there's no addition or subtraction. I can just do that. So now we multiply across the top. What are we left with?
2AB.
Times 4. Which gives you?
8B.
Awesome. I'm right. Then what are we left with? Don't stress. Do you need to simplify that further? God, no, because it won't be any simpler. Factorising is how we simplify, more often than not. Cool? Out the front. I just moved it to the front because A is before B in the alphabet, that's all. Yeah. It doesn't matter because it's commutative, it's a multiplication. It can be at the front or the back. Doesn't matter. Everyone happy with that? I crossed out those. I didn't cross out that. It's still there. The 4's still there. That and that. Cool? But one of the reasons that you factorise, when you're doing these, you factorise so that you get these things that you can cancel out. Is that cool? Okay.